We're now going to write linear equations, specifically when we are able to determine the location of two different points on a line. So in this first case right here, we have a graph to go off of, and we're asked to determine what the equation of the line is. And so here's our couple of points. And so one way we could maybe try to attempt to do this is we could go in slope-intercept form if we can determine the slope and the y-intercept. Or alternatively, we could also go in point-slope form, as long as we can determine the slope of the line as well as the x and y coordinates of a point on the line. And either way is going to be totally fine. It does turn out that in this particular example, the y-intercept there is a very nice number of 2. So very definitively right there, we know that's going to be a 2. And then you could also, I guess, find the slope right here, because if you've got two ordered pairs in the line, you can just use slope formula to find the slope. So really just take y minus y and then x minus x to get 9 over negative 6. But that's going to reduce down to negative 3/2. And so actually getting that into slope-intercept form kind of directly like that works out pretty nice. Now we know alternatively that point-slope form is also always going to work. So since we just used the slope formula to get negative 3/2, then we could put that in for the slope and then just use any like xy pair on the line. So like for example right there, you've got the point 4, negative 4. So the x coordinate of 4 would get substituted in right there, and the y coordinate of negative 4 would get substituted in right there. So right there you've got the subtracted and negative, so it's really y plus 4 equals, and then I'm going to distribute, so negative 3/2 x, and then a negative times a negative is a positive, and 3 times 4 is 12/2, but 12/2 is really 6, and then you can get the y alone if you subtract 4, so you end up getting y equals negative 3/2 x plus 2, which of course is the same equation that we got when we wrote it in slope-intercept form, like you saw there. Now there are going to be cases where you might be trying to write an equation of a line that passes through like these 2 points in particular, and those 2 points like are not on the y-axis at all, and there's no way for us to know where the y-intercept would be. So that means that really going in slope-intercept form directly isn't going to work. But if you know the line's going to pass through 2 points, right, you can definitely find the slope between 2 points, because just use slope formula, and then you can write an equation in point-slope form, because now you would have found the slope, and then hey, there's a couple points on the line, so pick one of them to plug into point-slope form. So it's not too bad right here. So if you want to find the slope, it's just y minus y, which is 1 minus 5, and x minus x, which is 8 minus negative 6. So you get negative 4/14, which does reduce down to negative 2/7 for the slope of the line. And then you can pick one of the points to go along with that slope to plug into point-slope form. So how about if we just choose negative 6/5? So in point-slope form, then y minus y is going to be equal to the slope times the quantity of x minus x. And it's not saying that we need to simplify this, because it just asks what's an equation of the line. So I mean, you could just leave it if you want, but I'll just go ahead and simplify this just because. So if we distribute, okay, that's a plus though, because we're subtracting a negative, we get negative 2/7 x and negative 12/7 there, and that's equal to y minus 5, and then we'll get the y alone if we add 5. So by adding 5 here, I want to turn it into 7s, because I want to combine with the negative 12/7. So it turns out that 5 is actually 35/7, right? 35 divided by 7 is 5. So then you can add those together. That gives you 23/7. So you'll end up with then y equals negative 2/7 x plus 23/7 for the equation there, now expressed in slope-intercept form. And then down here at the bottom is a pretty common type of question you might encounter in some sort of an exam relating linear equations and all that sort of stuff. And so what it says here is that you have a line with a slope of 1/3 that passes through the point 6,1. What's the equation of the line? And so like when you take a look at a couple of these options that are pretty similar in nature to each other, you've got 1/3 x and 1/3 x plus 1, which seem appealing because, you know, they're giving you a 1/3, and these lines would have 1/3 slopes. Now these ones don't seem to have anything to do with 1/3, but they're not solved for y, right? to like know the slope explicitly, you'd have to solve the equation for y and look at the coefficient of x. So since you are given like the slope and a point on the line, right, like one way you could tackle this sort of a problem is you could write this in point slope form, since you know it's a line. So you could write y minus y equals m and then x minus x, and then just do a little bit of solving with that. So if you distribute, you get 1/3 x, and 1/3 of -6 is -2, and then you can get the y alone if you add 1, and then when you add 1 to -2, you actually get -1 then. So the equation is y equals 1/3 x minus 1. So at that point, once you know the equation is that should rule out f and g, because none of them are like that. And so that would probably bring it down to just either h or I as the possible options. And so one thing you could possibly do is you could solve this for having it in standard form, where the x's and y's are on the same side, just fitting the forms here. So if you subtracted the 1/3 x, you're going to have -1/3 x plus y equals -1. And then since nothing has fractions there, you can eliminate fractions if you multiply by, say, like 3 on both sides. And then that would get you to x plus 3y equals -3, which really doesn't match any of those two equations. So, but if you take and you multiply by -1 to both sides now, then you end up getting x minus 3y equals +3, and that right there does match exactly with the option there in h. So then we would know that h is actually going to be that line described that's going to have the slope of 1/3 and then also contain the point 6, 1.